Thank you. How's everybody doing? We're into the home stretch of PuppetConf here. We're going to be talking about retrospectives, human error, failure, things of that nature, and it's kind of interesting that we're doing that today, given DNS issues today. My friend Pete Cheslak actually used to work at Dyn, and he had a saying: if Dyn is having a bad day, you're all going to be having a bad day, and I think that's true. So hug ops to the Dyn DNS team. I know they're putting up with a bunch of stuff today. So a look at looking in the mirror. One of the first presentations I ever did about DevOps was looking at the different sort of operational endeavors that humans engage in. And the presentation was called, "Is Your Team Instrument Rated?" And it made the argument that if we look at DevOps and we kind of compare it to some of the other things that we do in an operational context, what would that look like if we looked at it as developers as pilots and operations people as air traffic controllers? What lessons could we learn from aviation and that would apply to the work that we do in technology? And so there's a link to the presentation if you want to see it. But I wanted to start today with a thought experiment of an incident in what we might call the JFK data center. So this is at JFK Airport, and we're going to see what happens in this particular incident.
American 2 Heavy, Kennedy Tower, only 22 left. You're number 2 for the field. Traffic's on a 4-mile final at 31 right. Wind is 320 at 22. Clear to land, runway 22 left.
22 left, American 2 Heavy. Heavy visual for 22 left.
American 2 Heavy, 22 left. You're clear to land.
Clear to land. 22 left. Your localizer's not, Murray.
Okay, I will double check it. American 2 Heavy, they just reset it. Should be coming back up in a little while. Wind now 32023, gusting to 35.
American 22. We can't land on 22. We're breaking off approach, and if you don't give us to runway 31 right, we're going to declare emergency.
All right, I'll pass it along. Fly runway heading for now.
Okay, we declare emergency. We're going on 31 right. We're going to the left, and then coming around.
American 2 Heavy, just fly runway heading.
We're in the area.
Okay, you're saying you're declaring emergency at this?
3 times I've told you that. 3 times we're declaring an emergency.
Okay, I just want to verify. I know you told me if you didn't get 31 right, you would have to declare emergency. Okay, I understand. Fly runway heading, and I got to get you a turn.
No,
JetBlue 62, the left on Alpha and monitor ground to the ramp.
That's Alpha on the ground. JetBlue 62.
I heading 180.
You know, American 2 Heavy, we are turning around to the left here and landing on 3-1. Remove everybody from our way. We've declared an emergency.
Okay, so let's pause for a second. That doesn't inspire a lot of confidence, does it? I mean, I do a lot of flying. Some of you probably do a lot of travel as well. That seems kind of stressful, doesn't it? So, back at headquarters, you might have your leadership, your bosses asking, what happened in that situation? This is like a total breakdown in communication. What would our customers think if they heard this, right? They probably would have a lot of questions. They wouldn't trust us to do what we do every day. This is really bad. So, your task, your boss asks you, identify the root cause and who is responsible. So I want us to think about that. Your orders are identify the root cause and who is responsible. And so take a second to think about that. Do you think that the air traffic controller is responsible? Do you think the pilots are responsible? Should we take away the pilots' licenses? Should we retrain the air traffic controllers? It's an interesting question. What would you put 50-50 blame? Would you say maybe the pilots are 70% responsible or the air traffic controllers? So it's an interesting sort of thought question. The other thing that I would ask, was this event a success or a failure? So actually, by show of hands, who thinks this event was a success? Few people. Who thinks it's a failure? Okay, about equal. And then I heard somebody ask, did it land? Right? Who doesn't want to make an answer until they know whether or not it landed? Right, okay. So we're going to talk a little bit about that, because that's kind of interesting, right? We want to know the outcome. And of course, all the questions that I just asked you, another kind of thing is, like, would your answer change if you randomly then found out that someone you loved was on that flight? Would your answer change if I told you that that's how the the landing finished and there was an incident? What if I told you it was more than just an incident? Would that change any of your answers? So a little bit about me. I won't go through this whole slide. This slide's really about my Twitter name, so you can tweet me. I'm J. Paul Reed on Twitter. You can ask questions and throw Twitter tomatoes at me, whatever you want to do. One thing I will point out is that my background is in build release engineering, and I'm working on my master's in human factors and system safety. And the thing that I would point out is all of my classmates are like pilots and air traffic controllers and chemical plant engineers and nuclear power plant engineers and doctors, right? In fact, I'm the only sort of IT operations person in the class. So it really is, we're starting to look at sort of what all these other fields have learned about safety science and how that applies to us operating large-scale internet infrastructure and trying to do that in a reliable way that we can reduce some of these problems that we run into. I also note I've been involved in plenty of postmortem fun over the years. As a release engineer, we used to put software on plastic discs, right, CDs, and we put them in boxes, and we ship those boxes to stores, and you would go buy the software. You've not had a fun postmortem until you've put the wrong bits on the CD after it's been pressed and gone out of the shipping facility. I actually had that postmortem. It was not fun. It was not a fun postmortem. The other thing I'd mention, I'm a pilot, so pilots kind of have morbid curiosity with sort of accidents and incidents and stories, right? We kind of sit around the hangar on rainy days and tell these stories. So that's another sort of way that I got interested in this. So we're going to be talking a lot about the work that has been done, some of the research that's been done. These are a few of the books from people in the safety sciences that are doing research on this. David Woods, Sidney Decker, people like that. So we would be remiss if we didn't mention these people. That's Sidney Decker, who is also actually a pilot. He's a 737 pilot. Richard Cook, and then of course John Allspaw. People know he's the CTO of Etsy now, but he spearheaded a lot of this stuff. And in fact, actually, he was the first person that was in IT operations in the master's program that I am in now. So that's kind of how that got started, which is interesting. So one of the questions that get asked, John Allspaw is known for his talk about 10 deploys a day. That was his sort of seminal talk a few years ago now, about how can you deploy, can we do 10 deployments a day? And of course now it's like, of course we can. But if you remember at the time, that was like super insane. People were like 10 deploys a day. So one of the questions that we look at here in sort of the safety sciences, can we do that sustainably? How can we do that safely? What does safety actually even mean in this context? So again, some really kind of interesting, heady questions here. So those are all pretty mature areas. I said aviation, I said chemical plants, nuclear plants, stuff like that. And so a lot of times when those industries look at the way we do postmortems, they kind of have this, oh yeah, let me know how that works out for you, right? Because they're dealing with things that can really harm people. And so they kind of take a different perspective on it. And of course, the kind of interesting part is that, internet infrastructure and the stuff that we work on is now so pervasive within our society. We're actually sort of in that bucket. But they still sort of have, a lot of times when I'm talking with like the doctors or in my class, they're kind of like, oh yeah, they nod their head. It's like, I killed a patient accidentally and the website went down for 5 minutes and so you couldn't get your cat GIF. So it's kind of an interesting conversation. But anyway, so today we're going to talk about these things, how to fail at postmortems with these 4 weird little tricks, the mechanics of what's called a new view postmortem, and then how you sort of make this actionable and make it stick within your organization. So a very small digression about aviation. We're going to be talking a lot about aviation. We had that clip there. One of the things I do want to point out is that a lot of times the work that is done in an aviation accident investigation its purpose is to assign liability for the purposes of then court cases that follow. That's not what we're doing at all. That's not our goal here. And that's sort of one difference because a lot of times when we talk about accident investigations, aviation is kind of the gold standard, and we make a lot of parallels, but we do have to remember, right, this article, Boeing blames the pilots, and the pilots, blame Boeing, and the FAA could be a party to a suit as well. So that's a huge difference. Our goal is to be more like the NTSB. And they're actually doing some really innovative work. I don't know if you follow their Twitter account. They actually have been tweeting public parts of investigations as they occur. So it's actually kind of interesting the way that they've sort of become more transparent in recent years. One of the other interesting things is that, as I mentioned, the reason the FAA doesn't conduct these investigations is because they could be a party to the incident, right? The air traffic controllers work for the FAA, so there's sort of a separation of concerns, a separation of duties, and the NTSB plays that role. And so that's what we really want to look at. But of course, some of the techniques that they employ are, again, that's what we're looking at because they employ some of the state-of-the-art techniques in terms of retrospective analysis and that sort of thing. So a lot of you, this is sort of the traditional postmortem. I was having lunch with Damon Edwards, and he said, yeah, I can do your talk in a tweet. Speed guided postmortem is what the hell happened, why, that's what the hell happened, go write a test, meeting adjourned, right? How many people is their postmortem similar to this? Ask the 5 whys, we'll all get in a room, and then we'll write a test or put something in the backlog, and we're done, right? This is a pretty common sort of misconception about what postmortem sort of in a pop culture sense should be, right? And this is called the sequence of events model, sometimes called the domino model. And of course, because it makes sense, right? The idea is that if you remove one of the dominoes, then the accident wouldn't have happened. Or you maybe write a test, make a bigger domino, so when the dominoes fall, the one domino stops everything, right? And it's a very satisfying model, right? Because does anyone watch Seconds from Disaster? This show on National Geographic. It goes by other names. But I love this show because they have this ticking timer at the top of the screen. And it's like, tick, 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 it's like 30 minutes before disaster. Somebody did something very innocuous, but they have that ominous voice, and you're like, that's going to turn out poorly for that plane, right? And they keep counting down. And this is really what we're used to when we tell stories about failure, right? We tell a narrative. There's a story arc, right? But that is all a very linear model. And in fact, they say it's often mistaken for comprehensive causality, right? We believe that the story happened this way and that it comprehensively covers the entire incident. And it can be problematic, though. It's not really useful as a sole model because it assumes and in fact requires that we bound our system, right? And the joke in that tweet is we ask why. How many times? We ask it 5 times. Why? Why? Because we've heard about the 5 whys, and it's part of like Toyota production system. So this model actually requires that we bound the system often to those 5 whys. But there could be a larger system at play, right? We oftentimes don't look. And the answers that we get when we do 5 whys are really predicated on where we bound that system and where we look, right? And so the problem is that if you have this sequence of events model and you use it for doing your analysis, you really don't get the full picture, right? I mean, you don't get the picture in this instance. Maybe our dominoes fell off the table because we built the domino chain close to the edge of the table. Maybe the dog startled the person, and that's why they started knocking the dominoes over. Maybe we're operating our dominoes with a glass of wine, and that's why we had our domino accident, right? But we would never get to any of that if we looked at just the 5 whys, because it requires that we pick some frame of reference and we bound that system somehow. And what's funny too, when I work with clients and they do 5 whys, a lot of times people say they do 5 whys and they actually don't. They'll do like 2 or 3 whys. It takes a lot of work to get to the full 5. So this is the epidemiological model. This is a different way of looking at it, and it acknowledges that there's different subsystems in play. It identifies different types of failure, so latent and active failure. Latent, of course, being failure that is kind of baked into the system for some reason, either when it was built or because there's a bug in the code or whatever, but it's not causing a problem. And then, of course, it becomes activated somehow. So active failure is, I typed rm-rf /foo, and I put a space in between the slash and the foo, and suddenly everything's deleted, right? The other nice thing is that the epidemiological model accounts for different system actors, right? And we'll talk about that in a sec. So the common name of this is the Swiss cheese model, right? This idea that our system has a bunch of it's cheese and it's got a bunch of holes in it, and we only have failure when all of those holes line up and the latent and active failures come together in such a way that it sort of can cause this accident. The problem with this model is latent failures. If we could model the latent failures, wouldn't we fix them, right? Wouldn't we want to find them and fix them, right? So that's a problem. And then active failures, the problem with that is that there's outcome bias going on there. We're going to talk more about outcome bias shortly, but there's a problem with both of the ways that that's modeled. So ultimately, of course, too, this model is still very linear, right? I mean, obviously there's a line that all the holes have to line up and then you get your accident. So it's still a pretty, it's rooted in linearity. So before we get to the kind of better model that we use to talk about these things, I want to talk a little bit about bias. Different types of bias and how bias kind of plays into the way that we look at these things, because it helps inform like the model that we use to look at failure and incidents and accidents. So hindsight bias is the bias that with knowledge of the present, past decisions were clearly poor. And I, of course, model this sort of as a time machine because it sort of assumes that we could go back in time and like go up to ourselves and ask ourselves, are you sure you really want to type delete table from thing? Right? And of course, you in the moment are going to say, yes, failure is very implausible at this point in my life. I'm ready to press return, right? And if we were standing there, we'd be like, no, actually, you don't want to do that, right? So hindsight bias, when we ask those sorts of questions, it's really talking about a reality that doesn't exist. And that's why, of course, you would need a time machine to go back and interact with yourself, which is why it's flawed. You can really tell that there's a specific word for it. It's called counterfactual reasoning or counterfactual language. You can see this in postmortems or hear it actually, because people say, well, why didn't you notice? Or you should have done X. Those are all statements about a reality that just does not exist. So it's not super useful to talk about because you're basically talking about a reality that we would only have if we had a time machine and we could go back to 1985. Outcome bias is often called the stepsister, the ugly stepsister of hindsight bias. So we're going to take a look at outcome bias, and I mentioned outcome bias before. So, looking at these videos, you have this plane coming in, and it's like kind of odd, and the landing at the end looks kind of weird, but it's fine, and so, yeah, that's cool. And of course, as we do this more often, we might push our system a little further. So this landing's kind of a little squirrely, but, kind of made it down, and they, so it's okay. Maybe we push this a little further. This pilot got themselves into quite a situation. Their wing actually did touch the ground. But, they got out of it. They were able to go around, so maybe it's okay. And, of course, you have this, where it's a nice, sunny day, everything looks fine, and then that happens. Now, I doubt any of you would want to be on any of those planes, but which one got the postmortem? The last one, right? That's outcome bias, that we look at the events that happened as an outcome of what we perceive as a particular set of events or actions, and then based on what happened, we decide whether or not we want to look at it. Correspondence bias is one of my favorite ones, or it's also called fundamental attribution error. And I'll just read the definition. It's the tendency to place an undue emphasis on internal characteristics to explain someone else's behavior in a given situation rather than considering external factors. This is the quintessential DevOps bias, right? You've got, the thing I love about this is that these two, you got the developers and the operations people, and the developers, I want change, and ops, I want stability, and they're happy, they're smiling, right? And like the second they have to talk to each other, it's frowny face, right? And it's because, as operations people are like, oh, those developers just want to deploy all the time, they want to do these features, and of course they all suck because they're developers, right? We've heard some developer jokes, which as a person who was more in operations, I was kind of giggling, right? And then of course on the developer side, if you're a developer, you're like, those operations people don't want to change anything. Like they want me to deploy this on CentOS 2, how can I do that, right? So we oftentimes, sort of in a DevOps cultural context, will ascribe these sort of viewpoints and feelings to people just by virtue of their title. So that's one we're kind of used to. There's a great story. This is a clip from WHYY's The Pulse on the brain at the Franklin Institute talking about bias.
So what you'll hear is a sentence, a spoken sentence, that's been transformed by a computer to sound like gibberish. Any idea what they said?
No.
You can hear it one more time. Okay, now we'll hear the real sentence.
The Constitution Center is at the next stop.
Does it make sense that time?
Yeah, wait, was that the same?
It was the exact same sentence that you heard the first time.
No way.
It's the exact same sentence. Your brain is always using prior information to make sense of new information coming in. So once you know what the sentence is, when you go back and hear the distorted version, you can apply that information and it makes sense.
Isn't that wacky? The point here is bias is built into the way that our brains function. It's just kind of hard-coded in. Now, I forgot there's actually another video with some audio here, and I wanted to point something out. You know, there's this silly, surprising example because our sense and our perspective of where we are in this system, they're all too happy to conspire with our biases that are kind of always at play, always in play. There was this really fascinating video. We're going to watch it. This is from Facebook. And it was this big Range Rover that was stuck. And this man single-handedly got it out of the muck that it was in. And it's kind of amazing video that it only took one person to do this. So we're going to watch that. So a lot of times, just where we sit in the system can constrain sort of our perspective and our sense of the situation. And that can make it really hard in a retrospective context. So humans are just awash in a sea of biases. This slide is not even that, it's not even that innovative. I went to Wikipedia and I searched for human bias, and there's like a gajillion of them. And they've done psychological research on this and to varying degrees, and just the things that bias us on a day-to-day basis are massive. My two favorite biases, by the way, are the IKEA effect. The IKEA effect is the bias that even though we have a like crappy piece of particle board IKEA furniture, we ascribe more value to it because we were the ones that put it together than something else that somebody else built and may actually be nicer and have more value, but we put our blood, sweat, and tears into that crappy IKEA couch or bookshelf or whatever. So we care more about it. The other one that I love is the rhyme as reason effect. And basically the rhyme as reason effect is when what you say happens to rhyme, people will believe it more of the time. They've actually done research that says if you say something and it rhymes, the human brain's like, yeah, that seems reasonable, yeah, which is crazy. So we're just kind of stuck in this bias, and we just need to be aware of it, right? I'm not trying to argue that you can get rid of it, because you can't. It's so ingrained. But as a group, it can be useful to sort of be aware in a constructive way where we might be biased, because we can sort of sometimes see blind spots that other people have and help them see that. That's why it's important. So to understand the model we're going to explore next, there's this idea of work as imagined versus work as performed. So a lot of times you'll hear in retrospective context the blunt and sharp ends of the system. So the operators, the stuff that we generally are faced with, we're at the sharp end of that system. We're making the day-to-day decisions. We're in the trenches doing the thing, whatever the thing happens to be. And of course, as you go up, and talk more about organizational dynamics, the company, the organization, its role and focus, that's what we kind of call the blunt end. And actually, some safety researchers model this all the way out to societal government. Like, what does society value, and how does that influence our institutions? So this, again, we were talking about system bounding. This can actually go much further. But when we talk about the blunt and the sharp end, that's what that means. A lot of us, most of us, are probably at the sharp end or very close to it. So now we're talking about the systemic model. And that's the model that we do talk a lot about in retrospectives. It's like sort of the state-of-the-art model right now. So it models accidents as emerging from interactions between components and processes, right? So this idea that our systems are constructed of something, but then we also operate them, and accidents emerge from those interactions. It includes, components, processes, and actors, so us, across tiers of the organization. So it accounts for people like, our CEO or our CTO and the decisions that they make and how that affects what we do. And it also models it across time. So in ways that the other models kind of don't really account for. Probably the most important part of this model is it models failure and its success as an emergent property. And the important part here is it models success as an emergent property. So we're not just talking about failure. So let's, and it's kind of funny, we talk about, people have heard the butterfly effect, right? This idea, the part of this model is that it's more than the sum of its parts. And we have these emergent properties. So this is standard web application. I'm sure all of our applications look exactly like this. We've got our web server and our PHP, because PHP is dope. And we have our MySQL. And so we've got our web application. Of course, we want to get some web scale in there, so we add some load balancers to our application, right? And of course, then virtualization came along, so we got some VMware in there, got our VMs going on. Maybe we got some software-defined networking, some SAN. Of course, people are talking about Docker. So there's Docker. And of course, these applications all run on little virtual machines called JavaScript engines that run on the client side, right? And of course, we couldn't have one. We have to have two. So of course, there's multiple different versions of these little VMs that we have to have subtle differences to support things on the client. And of course, then we've got our people, right? So we've got maybe our database administrator who's doing her work, getting that stuff done. We've got developers getting their stuff done. And so you've got all of these people and all of these sort of things going on in your sort of complex system. So what's funny about this is that, as you add more and more people, we're kind of got modeling this. And then when you look at sort of like an outage, a lot of times it's like, well, wait, what's the deal with that car, right? And this weird stuff like that can affect our system. So I'll give you an example, right? There was an outage that was caused because a junior DBA ran a command because the senior DBA wasn't there. And then when they went and looked at it, it was like, well, the senior DBA, his car broke down. So that's why he wasn't there to help the person run the script, and that's why the site's down, right? So we live in this complex world where, again, if we ask 5 whys, we often are bounding the system in some way. But this is the reality that we're sort of faced with. I'll tell you another funny story, PuppetConf, that affects things. I was giving a talk once, and like 15 people got up and left in mass. And I was like, did I say something? And I had a friend who was with them, so I asked them after, and I said, what happened? And they were like, oh, the site went down. And I was like, really? And they're like, yeah, it turns out they sent the entire ops team to the conference, and so nobody was back home, and the site went down because we were all at the conference, right? So how many people are on call right now? No one? Oh, good. Half on call? Yeah. That's actually really good. It's fascinating to me that sometimes companies will send people to conferences and then make them work at the conferences. Like, you're not getting the full value of like being at the conference. So that's really cool. So the thing is that, okay, that's our application. That's complicated or complex. There's a lot of people going on. There's a 83 Tercel that's broken down that caused our database to go down. But here's the thing, is we all rely on, or most of us rely on, other services. So Amazon's a thing. You probably heard of it. We may have connections there. People that do payment processing, maybe they have a payment processor like Square. And the point is that all of those other systems are have the same system complexity going on inside of them, right? So suddenly it looks like this, right? We're relying on these systems that have the same kind of weirdness, right? So quickly it becomes very hard to model all of this complexity. You get into a situation like this where, it's like you've got dependencies going off to nowhere and there's all this craziness and suddenly, like, you have to ask yourself, like, how does the internet work at all? Like, I don't understand how we get anything done ever. So this is your application's actual architecture. This is a picture of the Higgs boson particle. And the point of the systemic model is that there's actors within a system, right? There's fields that affect these actors, sometimes entirely outside of their control. And there's sort of these beams of energy that kind of push particles around. This is actually what our systems look like. And you may say, well, geez, that's kind of confusing or weird. I don't buy that. That's crazy. I will point out, Mark Burgess has a book called In Search of Certainty. Mark Burgess, you probably know, father of CF Engine, father of configuration management. He's a physicist. And he's written a bunch of books and articles about how large-scale internet infrastructure is actually like physics. And what's interesting to me about that is a lot of the stuff that I've been working on, Heisenberg comes up all the time, right? This idea that we can know where something is or we can know which direction it's going, but we can't know both, right? We find that in our systems when you start to model people and hardware and software together, it takes on this quantum physics nature very quickly, which is kind of fascinating. So because of this, these are some common but false assumptions. The systems we work in are simple or easily understood, or at least if we had enough time, we could understand them. This is false. Therefore, our systems are inherently safe. Also false, right? That we could bake safety and stability in. That if we just had enough engineers, we could make it safer, right? That's also false. And this is one of my favorite ones. Priorities and goals are static and coherent. We all intuitively understand this, right? How often have we been working on a project for 6 weeks and then somebody comes in and says, yeah, throw that project away. We don't care anymore. We're going to do something else now. We're changing direction, right? So this is an assumption that we work in systems with static and coherent goals that don't change. But in reality, we all know they do. And then, of course, there are specific singular fixes that can solve the problem. This is, the magic bullet theory, right? Again, a common but false assumption. I'm going to talk a little bit about bad apples, a little bad apple tangent, right? And this comes up, Sidney Dekker speaks to this. Human factors, you have to assume that nobody comes to work to do a bad job. If people do come to work to do a bad job, then you are in the territory of sabotage of pathological behavior. Right? So a lot of times we might say to ourselves, we really think it's human error when we get together on our postmortems. We really, really think it's human error. This is kind of code for, we keep having postmortems because of Joe, right? But when you call people or put them in the bucket of bad apples, you're sort of missing out on some information that actually might be more useful. Dekker goes on to say, this is kind of a funny joke, reprimanding supposed bad apples may seem like a quick rewarding fix, but it's like peeing in your pants. You feel relieved and perhaps even nice and warm for a little while, but then it gets cold and uncomfortable and you look like a fool. This joke goes over oddly in different parts of the world. He's Danish, I think, so his sense of humor sometimes is odd, but that's what he says about how we interact when we call people bad apples. So we keep having postmortems because of Joe, but what else is going on in our system, right? Is there systemic burnout? Are we burning out our employees? Are there silos or hiring incentives? This is a great example of where an executive, a CTO at a startup had an incentive to fill a position by December. And he filled that position, and it was with someone who wasn't qualified to do the coding work. They just didn't know the language, right? And they ended up having to get rid of that person, but there was weird incentives at play. As a build engineer, at points in my career, I've been the sole build engineer for 200 developers. So you probably can imagine I'm going to be having a bad time, right? And I'm going to be overworked and probably making a lot of mistakes, which was the case because there's sort of resource mismatches. So conducting the postmortem, let's talk a little bit about that. And I asked, how many of you is the postmortem, hey, let's all just get in a room and talk about it. Talk about what happened. We'll maybe look at some logs or something. That's pretty common what we see when people conduct postmortems. Have people heard this term, blameless postmortem? Yeah? Does it feel weird to anyone? Where you hear blameless postmortem and you're like, that's not a thing that exists. I don't get it. I can't imagine what that would be like in our organization. By the way, if you raise your hand, I won't blame you, I promise. The reason it is actually weird when people hear that is because there's a sociologist named Brené Brown who talks about blame as a way to discharge pain and discomfort. We are actually evolutionarily wired to use blame as a coping mechanism. So that's why when somebody comes to you and says, hey, we're going to have a blameless postmortem, a lot of people kind of inside are like, yeah, right, the analogy I often make is it's kind of like going into a room and all of us pretending we don't have arms. Like we can see each other's arms, we can see our arms, but we're all just going to pretend like we don't have arms. And that's how we're going to conduct the meeting, right? I just want to acknowledge if blameless feels weird, you're not alone. That's pretty common. Another problem we run into is the connotation of postmortem, right? Postmortems are when somebody died, and you see that connotation being unproductive in different ways. Sometimes people are like, well, nobody died, so we don't have to care about this incident. We don't need to have a postmortem. When maybe, yeah, you actually should have a retrospective. But postmortem carries a pretty heavy connotation, so that's why we talk about retrospectives or learning reviews instead. I wrote an article, you can read it, about sort of blame-aware postmortems. I'm not saying we should change the name. I think blameless postmortem is pretty much caught on. But if you're curious more about some of the research behind it and why blameless is kind of odd, that article kind of discusses it at length. So what you should do first, debrief the actors. A lot of times, we will finish an incident and then we don't actually debrief until the postmortem. Right, we wait a while, or we get everyone together and then we debrief them that way. And of course, we just talked about bias. People are going to be biasing each other, so that can be difficult. What I actually suggest, what I like people to do is usually there'll be somebody who's going to run the postmortem. People, when they are done with the incident, should sit down, write up an email a narrative email of what they think it is, what happened, and what they did, and send it to that person. And that person then can collate that stuff. And then you would use that as part of your postmortem. But that's the debriefing the actors part. Gathering the data, we all monitor our stuff, right? So we should be able to gather our monitoring and metrics together and have that available in the postmortem. I would point out, it's kind of funny, how many people have heard of ChatOps? This is really good. I would ask that question like a year ago, and people will be like, ChatOps, what's that? And you tell them, they'd be like, wait, I'm deploying from IRC? Are you insane? And then, of course, this was like when Slack was newer, right? So, but now it's like Slack and HipChat. And people would just be like, why would you do that? ChatOps has a lot of benefits, but of course, one of the reasons is that when we go to do our retrospectives, the logs for everything, the timestamp logs of what we did and what happened and who did what, are all built in and baked in. Teammate is a tool that you can do sort of, it's like Screen, it works with Tmux, but you can do like, you can log into a machine and you can have like pilot, copilot, so that somebody debugging a problem, it's a shared mux of the terminal so that you can collaboratively debug things in real time, so that if you are working a problem, you can kind of do that sort of just two people that are focused on it, and it's not one person trying to make sense of everything. You can have people work together that way. So that's really useful. The point here is we want to construct sort of a black box, right? Aviation has this idea of the cockpit voice recorder and the flight data recorder that collates and collects all of this data. I will point out, if you want to have your infrastructure and tooling ready to support this. It's actually kind of interesting talking about incident response. VictorOps has a built-in postmortem report that will generate a lot of this stuff for you. And so a lot of infrastructure companies are starting to look at like, how do we make our products ready for organizations and people in the systems like you to be able to actually do a productive, actionable retrospective. Creating a timeline is super important. I can tell you that there have been a number of times where I've been with clients and they are arguing in a postmortem, and if you're actually not involved, so you have no dog in that fight, you'll notice that they're arguing about the cause of something and they don't agree on what happened. So someone is arguing about event A, and this other person doesn't believe event A ever happened, and they're arguing against that. And it's fascinating and also kind of sad to watch because they're never going to agree or connect about what actually happened. So creating a timeline is really important. There's actually 3 levels. There's what happened, and then there's adding timestamps. That's the next sort of degree of detail that you can add. And then the third is where they actually will add like the inflection. If you have an incident bridge and you recorded it, there's actually, you can annotate inflection in people's voices. And they do that more in like aviation. But I see a lot of tech companies recording their incident bridges and reviewing them now as part of the postmortem process. So start with the timeline. I would point out, up to now, everything that we've talked about, we're just trying to understand the facts. I'm a Law and Order fan, right? And so they talk about the finding of fact versus the finding of judgment. We're just to the finding of fact right now. We haven't even talked about how would we fix it, how would we remediate it, how would we maybe help people in that system do their jobs a little better. Haven't even got there yet. Once you do that, you kind of then go through this process of what I kind of call, for people that love calculus, repeated approximation, right? And you have to go bottom up and top down. And so what that means is you're going to look at this timeline that's going to have these items on it that has your data, your metrics, right? It should have what was done. If you have ChatOps, you'll know what was done, and then maybe if you have an incident bridge, you might have recorded what was said. And you notice there's these vertical lines, T1, T2, that's labeled in this graph. Those are events. Once you collate all that data together, you can start to come up with actual events that are useful to sort of review in a retrospective context. So what you do is, again, bottom down, or bottom up, top down. You keep going back and forth. So you might look, automation surprise, right? Is there a big gap in when people are talking? Are they surprised by what they saw? Is it automation surprise? Maybe not. I don't know. You might look at what the tasks of what people are doing, right? And how that sort of played itself out in the incident. Stress fatigue, right? Same thing. You might be looking, well, maybe it's not automation surprise. Maybe it's stress fatigue when you actually come back up and then look at it again from a high level and then go back down to the data. So the reason I say repeated approximation is because you keep going back and forth. And then you might conclude, yeah, it's automation surprise and fatigue. So path to remediation, this is the sort of making it stick part. I'm not gonna, the 2 points I actually wanna make is recommendations are predictions, right? So whenever we say, I think a lot of times we do a retrospective, we say, oh, we're gonna fix this problem, we got it fixed, and we'll put it in the backlog, and then we actually do it. It doesn't just rot in the backlog. And so we do that, and then we tell ourselves that will never happen again. It's impossible for that to ever happen again, right? One of the things I want you to take away is that recommendations are predictions. So we are running experiments when we go and fix these things. We can never really say, oh, we will never have that outage in that way again, because it's always possible within these complex systems. I'm not gonna go through all of these. SMART is a management acronym, so you've probably maybe have heard it before. The most important one that I wanted to point out here is your remediation's the last one, time-bounded. You should revisit your remediations on some schedule. Maybe it's a month, maybe it's 2 months, something like that. The reason being that your system changes. So the remediation that you had in place may not even be relevant anymore. You may be doing extra work. You may be not doing not enough work. Maybe there's another component of the system that has the same sort of fundamental flaw in it that could reveal itself, latent flaw in it, right? And so you want to apply that. So again, the other one that you see a lot is realistic or agreed upon, where we'll tell the ops team, hey, you'll just do this, but we won't give you any time to do it. Well, that's hard for them to do, right? I love Bethany Macri was on stage earlier yesterday talking about Morgue. It's an Etsy tool for doing postmortems. It's not attempting to replace Jira or any of those systems. It works with them. It helps you collect a lot of the data. You can check that out there. She worked on that. It's a great tool for you to sort of be able to collect and collate this data and sort of manage your postmortem process. Again, it doesn't replace your other backlog tracking tools. It's an add-on to help with that. All right, so what now? I want to leave you with a couple things of food for thought. Just culture and responsibility authority mismatches. The most important one about this is the responsibility authority mismatch. That's the idea that I'm not going to give you the authority to make any decisions, but when they go poorly, I'm going to hold you responsible, right? So in a lot of times in systems, especially in an operational context, this comes up, this issue, right? You see it with pilots where it's like the company really wants them to fly through this bad weather, and so they may order them kind of with a wink and a nod to do it, but then they hold the pilot responsible if something goes wrong. Incentives, we talked a little bit about those. Where are the incentives within your system, not only for executives, but for everybody? What do we reward, or what behaviors do we reward? Mini-mortems or pre-mortems, this is kind of an interesting thing. I see teams doing pre-mortems where if they've got a big site switch that they're going to do, they basically go and they sit down and they go through everything that could go wrong. They try to figure that out beforehand. And then so in the moment, they kind of prime their brain to possibly run into those things. And it's kind of interesting. It's not something you would imagine you might do, but it turns out to be useful. And this is typically not an incidents that come up randomly or in the context of just normal operations. This is like we're moving a data center and we're moving an application. Let's pre-mortem what we think might go wrong. So we're kind of ready for it. Public postmortems, I won't talk a ton about those, but you see a lot of organizations. Chef is big into this. They hold their entire postmortem on Google Hangouts. Anybody can watch them, which is kind of like, I say that to people sometimes and they're like, I don't know that we would do that at my organization. A group to facilitate postmortem. So this is the idea. If you're a medium to large company, you might put together an organization like the NTSB that helps teams facilitate their postmortem process and retrospective process, and helps them get better at that, and helps facilitate those so that sometimes the high level of feeling that people get involved, they can help take the edge off of that. And of course, second and victim effect, I won't talk a lot about that either, but that's the effect where people that make mistakes or induced failure, we often all take our jobs very seriously, and so they take that very harshly, right? There's this story about a second and victim effect. There was an air traffic controller that ran a couple of planes together, and there was a wife and a child on the plane, and the husband, who was not on the plane, about, I think, 6 or 9 months afterward, came and killed the air traffic controller. That's second victim effect, right? And hopefully, we don't have that in operations or IT operations, but you do see it in people being depressed, burnt out due to an event, because they take their work seriously. Last two things I wanted to mention, garbage in, garbage out. Incident response. If your incident response is not particularly practiced or rehearsed, your retrospectives are going to kind of be messy because your incident response is messy. So those two things go hand in hand, incident response and retrospectives. The other thing I would mention is scheduling retrospectives. How many people have this situation where they basically say, there's an outage on a Wednesday, you fix the outage on Wednesday, and then on Friday, because you didn't fix it quite right, the outage happens again. So you say, oh, well, we're going to have a postmortem on Friday, but then we don't have it because the outage happens again. And then on Friday, you're like, okay, that sucked. We're going to go to the bar and have a beer. And so we'll move the postmortem to next Tuesday. And then you find out next Tuesday, the main person involved is on vacation. So then you schedule it for the week after when people come back. And then you end up having this retrospective like 3 or 4 weeks after the incident happened. One thing I will tell you, if you are doing that, then that retrospective process is totally useless. You are just talking about you're in an environment where you're just going to be remembering things that probably, possibly didn't happen. You're going to be using, there's a specific bias whose name I forget, but you're just, you're not going to get good results from a postmortem that happens weeks after the event. Language is super important. So this is the last 2 slides here, my 2 major takeaways. Language is important. If you are using these words, stop using these words. Root cause analysis makes me cry. Best practices makes me cry. If that seems weird, find me after, I'll explain why. And also, we started this exercise with identify the root cause and who is responsible. You'll know that's not the right question to be asking either. Thanks.